Hello,
Hello.
good afternoon, everyone. Welcome to Liquid Brain. So, today it's gonna be both of us around because we're gonna have our part one, I would say, of the updates on our Liquid Brain Impossible October Challenge. So, if
Yep.
you don't know,
Oh, yeah.
2 weeks ago we put out a video. So, both of us has give each others a task, which is quite difficult, but not really. And our deadline is actually the end of October. And this
Yeah.
is supposed to be the part one because we have both not finished our task, even though the timeline is up. Life is busy, so yeah, we're gonna make a multi-part video series again. So before I start, I think I will need to re-explain the the
The task.
rules of it. So the rules are
Okay.
very simple. We have 2 weeks. We challenge each other a task that basically we know and can be done in 2 weeks' time. Okay, so my task for her is to animate a UMAP object so
Mm.
that during the UMAP clustering process, we can understand how does the clustering algorithm work. Either it can be through a animation or you can do multiple frames or any other way to show the progress. So I think Lindsay, can you take it over?
Alright. So my task for you is to get the survivor analysis for the TGGA, the cancer database, breast cancer TGGA BRCA data. So yeah, and specifically, I think the survivor analysis for the TP53, right?
Yep.
Mm. Yeah.
Okay, so I think I have to apologize to the audience saying that, oh, it's very easy to run survival analysis because obviously it is not. And the curveball here is that instead of actually asking me to do like a survival analysis on the race or
Mm.
family or any other threads that's inside the TCJ database, she wanted to do it on a gene expression. So we actually have to run another classification. So we'll do that later. But first of all, Lindsay, do you want to walk us through your progress on the UMAP? I think I'll
Yeah.
allow you
So
to share the screen here.
okay. Yeah. Can you see my screen already?
Yeah, let me move it a bit.
Yeah. So
Yes, we can do it.
your task, I don't really know whether I fulfill or not. But anyway, this is how I understand UMAP in my own way. Okay. So this UMAP is actually like the so-called universal manifold and or is that A already?
Approximate, I think.
Yeah, approximation projection. Yeah. So that's the very easy way, which is I just input the iris data set, and then I will just run something called UMAP. They will just help us to classify and plot the result. So yeah, this is what I can do already. So
A
I've
moment, let me
done this
shift our face a
already.
little bit so the viewer can see what happens. Okay, please
Is
continue.
it okay? Yeah. So this is yeah, very easy. I have already kind of like they kind of separate them these two like more closely together, and then this one is like apart from them. So I think this is how I understood UMAP previously. Yeah, they just did whatever thing at the background. So let's say we want to explore what are the parameters that we can try to adjust to make sure that they can separate better, or maybe yeah to visualize better. So they are actually having four parameters, right? So the first one is called n neighbors, the number of neighbors. So this is the number, I mean the number that you allow them to be the within the cluster, right? So this is to get the like let's say the smaller number means that we will try to separate them more. Okay, means that you will just retain smaller number of the points in one cluster. For the high, I mean for the larger number means that we just want to get a global structure. We want to get the overall picture, big picture. So let's see how they are different in different number of neighbors. And yeah, I still need to process it. Can you see my script here?
Yep,
Is it okay? The font size?
yep.
Yeah.
Perfectly fine.
Okay. Yeah.
Anyway, we'll just both upload our script to a GitHub repo later on. I think there'll be two GitHub
Mm-hmm.
repo because there's two of us. But you can
Mm-hmm.
find all the script in case you cannot see. You can find it in the video description down below.
Yeah.
And so can you talk us through what it is actually currently doing? It seems like you're running a
Okay.
loop of some
So
sort.
Yeah, so this one means that the loop is I want to get the data frame of the result of UMAP. And then after get this data frame, I want to convert the data frame into long data frame so that I can plot in the Gplot. The Gplot is like, you see, we have the UMAP 1 versus UMAP 2. So let's say this one is the n neighbors, which means that, like, let's say 4, they will maybe can separate better. Maybe I zoom and let you see separate better. So even within the same cluster, you still can see like they are clustered into some subpopulation. So let's say in the higher n neighbors, you can see that they are just maybe like within the same data set, they are still, they are clumped together. Okay, so this is how we can adjust this n neighbor to visualize the thing according to your need. Okay, so the next one is the minimum distance between embedded point. So
Before that,
this
can
is
I
like,
can I check the audio level because you're not recording on your side?
oh,
Can you speak a
really?
little bit?
Hello, can you hear me or not?
Yep. Okay, that's me. Okay, that's good enough.
Okay.
So I will cut
Okay.
back to this. Okay.
Okay, so it's okay, right? So now, okay, so this is actually, just make it easier. The lower the point, the smaller the number means that we can allow overlapping of the point. And then the higher means that we let the point to be visualized in the surface, okay, in the graph. Okay, so this one again we can check how it look like. I should actually run this first. Meanwhile, do you have any question? Do you think I'm on the right track or
Do
not?
you write the map.df chunk of the code or is it copy paste from somewhere else?
I just get something from the website.
Okay. No,
Yeah, but this is very simple.
it's a very high level code on a
Really? Oh,
combination
okay.
of plots as well as the loop.
Yeah. But
Yeah.
anyway, just very simple. You just like run UMAP and
Yep.
then change the data frame into the long
Yep.
data frame so that can be plotted.
Yep.
Okay, so this is how how we change the min max. Like you see, the minimum min disk will just lead to the lower overlapping of the point. And then let's say we have more, so they will separate better. Okay, so the next one is the distance. Distance actually is more on the statistical method, like how they can formula, they can do the formula for the distancing between the point. So this is like they have a lot of the statistical formula. Is it something like that? Distance formula. So yeah, this is the Euclidean is the one that is quite familiar, and we still can use other types of the distance method. Okay, and now you can see.
Oh, wow.
Yeah,
This
so
is amazing.
it's kind of I don't know which one can be used, but anyway, normally we can just treat whatever that we feel like comfortable, that we still feel that is useful. Okay, and the next one will be this one, the n-epoch. Is it called n-epoch? So this is actually
yeah.
epoch.
Yeah, I don't
epoch,
think it's
and
English.
then this is actually the means iteration. Is it iteration? Yeah, that means
I think.
iteration. Then
One of them.
in my understanding is like we can divide the data into how many batch.
Yeah.
Okay, so like let's say 20 batch of the data, or let's say 1,000 batch of the data. So from there they will try to train or try to cluster based on the batch of the data. Yeah. So this one also kind of like having something different, I think. Yeah. So would be something like this. Yeah. So means that it's like higher, means they can cluster better, or is it lower cluster better?
They will usually reach a saturation point where the clustering no longer improve. So I think 20 will be too low. And I would say around 500 will be the sweet spots of the clustering. And if you go over, I don't think you produce a better result.
Yeah.
Yeah.
Something like that, right?
Yeah.
Okay, so this is also allow us to try to fine tune the parameter. I actually think that here to be okay already, but I also found another script that can let us to see the interactive UMAP plot. Maybe I also try to run it a while, and and this is also a script that I just got it from. I'm not sure can I just get it or not. I want to see. Yeah, so still able to do right. Yeah, so this is actually just to let us to see what are the point that yeah for this uh for this data set, and then the other one is the 3D.
Yeah.
That's all. Yeah, and I will just stop here because I think initially I want to do the animation of how animation of the parameters while they change how the figure look like, but I don't really settle it yet. So maybe let's see whether can I do that or not.
Yeah, that will be a part of our November challenge,
Yeah,
I suppose. Okay,
yeah,
so
this,
yeah, to be honest, I'm very impressed with the number of details inside UMAP have you presented.
oh
That was
really?
way beyond my expectation. I thought you would just do like a single parameters for this n-epoch, but you also explain things like the distance and all the other hyperparameters that you talk about just now.
Yeah, something
So
like that.
I think I mean since we have a month, can I add on another task to actually not just do the animation on epoch, but also
Oh, okay.
try the different distance and neighbors.
Okay.
So that we have a multiple view of three things, I would say. This doesn't make the clustering mechanism doesn't make any sense. So I don't think we can transition in between them. But the number of neighbors, the number of the neighbors and the
The
epoch.
mean
What is the other one up there?
and mean distance, mean
Yeah,
distribution,
yeah,
mean distance.
mean distribution. I think you can actually do three. I think that will really give people an idea of how UNLP actually functions on these three
Okay.
hyperparameters. And when they are doing their own what is that called optimization, they would know which one to adjust. I think this will be very helpful for a lot of people, me
Yeah.
myself included.
Okay.
Yeah.
Actually, same as mine. This is really very useful for the single cell analysis. I think
Yeah.
for the clustering part.
Yeah. I was going to do a UMAP video. I don't think I need to do it now.
Oh, wow.
I think this
Okay, then
explains most of the concept of UMAP and how it functions.
yeah, I think still a lot that we need to know.
There's always more.
Yeah. So should, is it should be your turn now?
Yep. Okay. So
Yeah. Then
okay.
stop
So
sharing.
I mean it's been a while. So do you want to re-explain in like a short 5-10
For
seconds
my
on
things.
what is the task just now that you do for me?
Oh, for yours one. Yeah,
Yeah.
I think I just want to get the survival analysis for the like whether overexpressed or not. I mean whether the overexpressed of the TP53 gene having any effect on the prognosis
Okay.
of the breast cancer patient.
Okay. So yeah, a very simple one-word sentence, which is end up to be like weeks and weeks of work.
Oh, I see.
No,
I
not really.
forgot how I do it already.
Not
So
really, not really. I don't need so much work because I am using your code directly. So let's just meet, since we are talking a little bit about story, let's just start from the beginning. So the first thing that I do is actually go and find what is that called, data cam. So you can see data cam. I will put the description. Sorry, I'll put a URL to the original script in the description so that in case you want to see. So the concept of them trying to do this is very simple, which is how do you get a Kaplan-Meier KM plot on this ovarian data set. So the ovarian data set is very simple. There is their time and there is their different age, different groups and all the other prognosis and all these things. Okay, so we are predicting the time based on all these other factors.
okay.
Okay, so very simple. You can either do it based on RX2, you can base it on RSID or Econ PS2, which none of you understand what it's trying to do. But basically, there's different factors that will affect the prognosis. So for example, let me just go for this here. These are not important, it's just as timing and these are the modeling, and yeah, this is the important. So for example,
Okay,
if you're
now you got
in
it.
group A and group B, this is your survival probability based on, I think, FU time. Yeah, is it called FU
Yeah.
time?
I don't know. It's something else, right?
So it's the time of, I think,
time.
that death or something. Yeah, survival time or something
Yeah.
like that. So that's their survival probability with a p-value of 0.3. So obviously not very significant, but the concept is that. Okay, so if you want to do some other thing, of course, you can just do, I want to do based on REST ID. So this is the REST ID of no and yes. And this is the prognosis on the survival and all that thing. You can also do it on multiple different parameters, RX2, REST ID, age group, and econ PS2. So multiple factors and how it affects the survival of a patient. Okay, so
I
I'm
see.
here, I'm pretty confident because it looks like the code to actually run this is just 2 lines. Right?
Yeah.
Straightforward.
Yeah.
And then this
straightforward.
is what happened. Okay, so
Okay.
so I actually copied the whole thing from your survivor analysis tutorial. Again, I'll put the
Okay.
link, the video to, you can see it on the link somewhere on the video bubble. And I'm not going to go too deep into the detail of how individual chunk actually works, but I'm going to show you what I changed. So roughly, these are about 25 million different package you need to install in order to run this. So what you essentially need to do is that you need to go to GDC project and identify the project ID and the category, experiment strategy, and workflow type that you want to run. So that would be this one. And you need to base on the different naming of the summary. So is there a name of different object here? Yeah, for example, I'm running breast invasive carcinoma. So in this case, the breast cancer project group. You can also run it based on like the colon, ovary, angiosarcoma. I think that's blood cancer or something. Okay, so different ID will result you to downloading different type of projects. So I'm running breast cancer, so I'm running TCGA, BRAC. So that will be the breast cancer platform. I'm doing transcriptome profiling because I'm running a gene expression studies and comparison. So this is the one that I do. You can also go for things like simple nucleotide variation. That would be on genetic markers. You can go for proteome profiling, sequencing, read DNA methylation, and all the other stuff they have in. Okay, so since I'm doing transcriptome profiling, I'm running RNA-seq and I'm running HT-count. So there's several experimental strategies like microarray, if I'm not wrong, and I don't know if chip-seq is one of it, but there's many strategy for RNA-seq, and this is the one that, there's many strategy for transcriptome profiling, and I'm using RNA-seq, and I'm using a workflow for HT-seq-count because it was done by you, and I just keep it that way, and it works. So
because this is the raw data.
Yeah, that I think I'm sure there's many other type of data that you can download and in different workflow.
I think got 3. So far that what I know for the TGA database.
Yeah.
It's 3.
Yeah, and there's multiple count type, like if I was saying that.
Yeah.
If you don't use HT count, you can use feature count salmon.
Another one is the FPKM, something like that, normalized already, but this is the raw count.
Yeah, something like that. Raw count, normalized count, different count method, different strategies, and so on. Okay, so all this, they're not important. They're just there to show you the data and what is it about. If you want to look at it, these are the thing, and I think this will be more important. So what are the features inside our database? As usual, we have a lot of solid tumor and very little, we have a lot of primary tumor, less on solid tissue and less metastatic because maybe they don't survive as long, and usually when they come in, they're all in primary tumor. Okay, so now we're gonna ignore the metastasis because they're too big, so they're too small, throw them out. So do another query, and then once we finalize the query, we're gonna download the data and inspect all the data individually. This step alone takes about 25 years. So just prepare to wait when you're running it because there's a lot to download and a lot to process. And I don't know why it has a very high GPU count on mine, which is very funny. Okay, so same thing. These are just some of the inspection of the data and understand how it works and save as an object as RGS. And then we're gonna go into Lima. If I'm not wrong, it's linear modeling of stuff. So Lima would actually decide which gene are over and under expressed based after the normalization. You can correct me on that. I'm not very familiar with Lima. Okay, so once we're done with Lima, we're gonna use the RDS, all the cancer data that we have. We use a Lima to identify this is overexpressed or underexpressed, and we do a normalization on it. And this is the what happened on the principal component analysis. So this is the spread of data, as well as how many of them are primary solid tumor and how many of them are solid tissue tumor. So in this case, we are not considering two different groups as long as they're normalized, because TP53 should affect the same way for one and another. So they shouldn't be different, so that we are aggregating them as the same group for analysis. Okay, and then these are just another a little bit more information about the clinical detail from the TCGA, and we're gonna actually run for how many of them has disease and how long it takes, so that we can take again all this data back in finally into our survivor plot. So in this case, we are doing a survivor feed. So this one is the actual run that actually run our survivor modeling. So if you can see, this is overall survival versus and the disease versus the race. So if you're just running on like some other category of data, for example, does the race makes any difference to the survival? This is how you can run it. Okay, so not too difficult at this step. I thought I was done. So you can see that the race, for example, who survived the longest here? The purple one has disappeared. I'm not sure why.
Can't really see.
I think it's part of my resolution change issue when I use a different computer. But you can see that the black African has survived much longer than Asian in this case. Or they just not have enough data to show the time after maybe 4,000 days or something like that. They just don't have enough data for Asians in this case. So, but we can roughly see the different trend of survival for different groups of people, which is great. Now we're gonna finally go into the gene expression. So before we gene expression, we have to make sure that they are properly normalized. So again, we're gonna run a Lima on the, what is that called? Something wrong. So we're gonna run a Lima. So in this case, we're running on a generalized linear model using like the GLM model, and we're running cross validation on this thing. So if you don't understand what it means, it just means that we want to make sure that the overexpressed are overexpressed and underexpressed are underexpressed. Okay, we're making sure that the model is able to differentiate between those two. Okay, so these are just the coefficient of the study, and if your confusion matrix show 100% correct, means your model works fine within the sample group they're running. Okay, so that's just classification and normal supervised learning situation. Okay, so coefficient with non-zero value, again, just more. I'm not going to rerun this again. I'm not sure what have happened there, but basically what that means, they're just data on the normalization, and we're going to get all the gene names so we can plot them later. Those are not relevant and not important for what we're doing today, because what the Lima is trying to do is that they're trying to select the top 100 gene with the most differential expression within the sample group. But we're not looking for that. We're looking for just a single one, which is TP53. So I ignore the whole thing. And what I go to is to change these two lines. Okay, so I search for TP53 on Ensemble and try to find what is the Ensemble ID. So what is that? I will change, instead of the original list of gene, I change the gene ID to a single one, which is ENS 000141510. And I'm going to put the gene name as TP53, which corresponds to this Ensemble ID. Okay, so again, I'm going to keep everything as it is, and I'm going to box plot as a survivor or healthy. So these are the original gene that Lima has told us that has the most differential expression among the sample group that we have. And it should be interesting for you to look at the survival of this group of gene. Okay, TP53 is not part of this list, so you cannot actually fish it out directly. Okay, but yeah, these are the distribution of gene expression between the disease and healthy. So something you might want to look into. And if you're doing something like exploration, you want to find a gene ID to run. That would be something interesting that you can look into. But if you're not and you have you just have a what is that called? You just have a task on the end of the month to run. What you need to do is go here and then do this feed. So as we talked about just now in the data camp, we are running a model. So in this case, we are running a survival model from over survival and disease compared against gene. So the gene refers to this gene. Where's my gene? Okay, my gene just disappear.
No, here, there.
Where is it?
You put it in the one column of the clean DF. Yeah, so the gene is that let's say gene value is median. Yeah, the 413.
413. Oh, yeah. Okay, yeah. Correct. Okay. Yeah, so basically the gene is up and down based on the comparison between the median value. And then I'm going to fit this gene data, which is my TP53, from the clinical ID and run my survival plot, which means it will be like that. And TP53 is either up or down. And I think the number shows that if it's down, you have a higher rate of survival, possibly.
Yeah. Oh, so you have done it.
Yeah, so this is done, but I have also promised a linear review animation, which I did not done because I don't have time to do after the whole set of things. And I'm not exactly sure where's the gene value. Yeah, it should be. I'm not sure this exactly is correct. I might need to look at it. It should be correct. Yeah, the map in gene ID.
Correct,
yeah, it should be correct. It should be correct. So these are the survival probability within the sample group based on TP53. But what I need to do now is to extract the raw data from this plot and then pipe it into ggAnimate for me to do a transition view.
Yeah, that one I never do before. So I will want to know how you actually do that.
Yeah, that will be my task for the next few weeks.
Yeah, I think you don't need any add-on task also.
Well, I have more. I'm not done.
Yeah, that's enough. I think it's a big task for the ggAnimate.
Yeah.
So far, yeah, I think that's nice because you actually, I think you also understood also like the whole flow. Then only you can come up with this thing.
Yeah, of course, I have a very good source of knowledge, which is the Liquid Brain video presented by the Lindsay from over here.
No, but actually, there actually two types of the survival model, survival package that for to use. That just now you use the survive minor, yeah. And actually another one is like copy, which like just now you use for the data camp.
Yeah.
That one is also another one that can show the statistics clearly, and also the one we can see the we can look into the p-value for each of the individual comparison.
Yep.
So yeah, anyways, that is like two different packages that we can use like that.
Yeah, but I feel like end of the day, people are watching a video, so having some nice looking graph is always an advantage. So I've been always trying to do more of a nice looking thing rather than actually useful looking.
Yeah, this is the one that can produce the figures nicely. But that one you need another ggplot to help to visualize that.
Yeah. Okay. So just a re-summarization of your task. So you will need to finish up the animation, which is I think you're doing on Shiny, right? Or are you gonna do ggAnimate?
I'm not sure.
Okay, either one of them. Yeah, so you can always do.
I got to explore.
Yeah, you can either do one of them, and you're gonna do distance, minimum neighbors, and epoch.
Do you think it's like the interactive one, and then we can adjust like on the spot one?
Shiny, yes. Shiny is the interactive
Shiny,
one.
yeah. Okay. But means that 3 parameters can be adjusted together.
Yeah.
In the same.
Same place. Yeah. Then you can adjust 1, 2, 3, 4, 5, and representing different value. Yeah, Shiny can do that quite well.
Okay, I will just try.
Yeah. So I will be continue with the extraction of the survival plot using the raw data and then pipe it into ggplot to do the animation of the drawings. That should be interesting.
Yeah, bye. Really
Okay,
nice.
that's all. Thank you for watching.
Okay.
Anything from you?
Yeah, like see. Look forward for our animation challenge next week.
Okay, like, subscribe, comment down below. Bye.
Yeah. Okay. Bye. Cut.